Hi, Algebra 1. In lesson 4 here, we're going to be looking at how do we finally solve a quadratic. Now, some of this is going to feel very familiar from Unit 6. So here we go. In our first equation here, we have 6 plus 2a equals 0. Now, I know that 6 plus negative 6 would equal 0. So this piece here needs to equal negative 6. Well, 2 times negative 3 would be negative 6. The other way to look at it is to set up like an equation that we've done all year, and you would still get a to be negative 3. In the second one, we have 7 times b equals 0. Well, to get 0, I'd have to multiply by 0. So b here needs to be 0, because 0 times anything is going to be 0. Similar situation on the next one. C is going to be 5, because 7 times 0 is going to get you 0. So this piece here needs to equal 0. Well, how do I get that to be 0? Well, C needs to be 5. 5 minus 5 is 0. And in the last one, we have lots of possibilities, but as long as either G or H is 0, then the whole thing is going to be 0. In these first two, you can probably just tell by looking at it. In this case, at x needs to be 3, because 3 minus 3 is going to be 0. Here, x needs to be negative 11, because negative 11 plus positive 11 is going to be 0. And then in this one, it's maybe not as easy to tell just from looking at it. So maybe we set up an equation just like we've always done, and I work to get x by itself. So I'm going to subtract 11 from both sides, and then divide both sides by 2. Whoops, made a mistake right there. There we go. And I end up with x to be negative 5.5. That's going to make that 0. In number 4, I know that anything times 0 is 0. So first, x right here could be 0. If that x is 0, the whole thing is going to be 0. And then next, I'm looking in parentheses, this part could be 0. And it might not be as easy to tell what x needs to be to make that part 0. So I'm just going to set up my own little equation off to the side, and we're going to solve it. This should look familiar from one that we just did. And we get x to be negative 5.5. So the other solution is that x could equal negative 5.5. So there's two solutions here. X could be 0, or x could be negative 5.5, and the whole equation will equal 0. Number 5 should look familiar from what we've done before. I'm looking at what does x here need to be to make the whole thing equal to 0? Well, it could be 3. And then over here, if x was negative 11, the whole thing would equal 0. So again, two solutions, 3 and negative 11. In number 6, I have two pieces being multiplied together. In the first one, if that is 0, the whole thing is going to be 0. So here, if x is 3, the whole thing will equal 0. And then in the second part, 2x plus 11. And again, that might be a little bit tricky to figure out just by looking at it. And so we could set up an equation to figure out what does x need to be to make that part equal to 0. And I would get x to be negative 5.5. And we've seen that a few times now. But if you're ever not sure, well, what does x need to be to make this part equal to 0? Just set up your own equation off to the side and solve it just like any other equation. Number 7 is a little bit different than what we've seen so far. We have 3 pieces all being multiplied together here. So this first one, if that equals 0, the whole thing is going to equal 0. So that's one solution. In the second one, I can see if x equals negative 3, the whole thing will equal 0 because negative 3 plus 3 is 0. And then in this last one, here's where it might not be as easy to tell. So I'm going to set up an equation, 3x minus 4 equals 0, because again, if this piece equals 0, anything times 0 is 0. So I have my equation set up. I'm going to solve it just like any other equation from the year, and we will get x to be 4/3, or we could write it as 1 1/3, same thing. But here we have 3 solutions to this one because there's 3 pieces being multiplied together. Here we have an equation for a projectile going through the air written in 2 ways. We have standard form and we have factored form. Which way, standard or factored form, allows us to use the zero product property, that's what we've been doing, to find out when the height of the object is 0 meters, or when the whole equation equals 0. So if we want to know when the height is 0 meters, I'm looking to know when does the equation equal 0. And the factored form is going to be much easier to use to find that, because I could look at each piece and figure out, well, what does t need to be to make the whole thing equal to 0. So now we're going to use that factored form to figure out at what time t is the object 0 meters off the ground. So I rewrote this showing that 0 is going to equal this, showing that the height is 0. At what time t is it going to be 0 meters off the ground? The second part here is easy to see that t is going to be 6, because 6 minus 6 is 0. Anything times 0 is 0. The second piece is not quite as easy to see. So I'm going to set up an equation. And I want to know, what does t have to be to make just that term equal 0? So I'm going to solve this just like any other equation. And we are going to get negative t to be negative 3/5. Now, if you're thinking about what makes sense and what doesn't, t is representing time here. So does it make sense to have a time that's negative? No. It only makes sense to have a time that's positive. So 6 seconds is the only one that's going to make sense. After 6 seconds, this object is on the ground. Now, even though this negative time doesn't make sense, it is still a solution to the quadratic. It's just that because this is more of a real life situation, we know that it's not going to be meaningful to us.